All right, algebra students, sorry for the previous video. Forgot to click one button, the microphone on button. So I'm going to re-record this. Let's look at problem one. We're going to cross out this getting ready problem because we're going to cover it later on in the notes. But solving by graphing. Okay, so before we solve by graphing, you got to know what a solution is to a quadratic equation. So we know from our notes that all quadratic equations are going to be a U-shape, something like this. Okay, and the solutions are where this parabola crosses the x-axis. This is the x-axis, the horizontal axis. Okay, so the solutions are these 2 points right here. Okay, so you could call them solutions. You could also call them x-intercepts because that's where it crosses the x-axis. Sometimes you might hear it in the Khan Academy videos called the roots because it's kind of like a tree growing underground where the roots start, something like that. Or it might be called the zeros. So those 4 things, they all mean the same thing. They all mean these 2 points right here. All right, problem 1. What are the solutions of each equation? Use a graph of the related function. Okay, so I got x squared minus 1 equals 0. You could always make a table. I have x and y. I could find the axis of symmetry, negative b over 2a. Here's a hint. If b doesn't exist, there is no b value here. There's nothing next to an x. So if b is 0, then the axis of symmetry is always going to be the y-axis. I'm highlighting that in yellow right there. Okay, so this is going to fold across the y-axis. So if I just plug in 0, I'm going to get negative 1. If I plug in 1, 1 squared is 1, 1 minus 1 is going to be 0. If I plug in 2, 2 squared is 4. I'm plugging it in right here. So 2 squared is 4, 4 minus 1 is 3. And I can plug in all these points. Okay, my graph is going to look something like this. I could reflect these points. We learned that in our previous notes. So I only have to graph one side of it, and I can just reflect the other side. So what are the solutions here? Well, the solutions are these 2 points. I'll use purple again. So those 2 points. So it's 1, 0, and negative 1, 0. So those are the solutions to that one. Okay, try B and C. So pause the video, try B and C. Okay, assuming you've paused it. This says x squared equals 0. Okay, so x squared equals 0. So what I can do to graph this, I can just change this to y equals x squared. Okay, so when it says 0 there, if you want to find the solutions, you can just plug in a 0 because you want to know when the x values, the y values are going to be 0, what the x values are going to be. Okay, or I can graph this. So we can make a quick table, but we should know that y equals x squared is going to be, the simplest quadratic equation. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I get 4. If I plug in 3, I get 9. So it's going to look like this. And if I reflect those points, it's going to look something like this. Okay, and this thing here only has one solution. So there's only one solution. And the solution is the origin, which is 0, 0. So it's possible for something to have only one solution. It comes down, it barely touches, and then it dips, or it goes back up. Okay, let's look at x squared plus 1 over here. Same thing, we can make a table. I know that from looking at the graph, negative 1 is shifted down 1. Y equals x squared starts at 0. So this one is just going to start at 1. All right, and I can plug in some points if I want to. Plug in 0, I get 1. Plug in 2, or plug in 1, I get 2. Plug in 2, I get 5. So I can also plug in points there. But you're going to see that this is never going to cross the x-axis. Therefore, there is no solutions, no roots, no zeros. Okay, so no solution there. All right, what are the solutions of each equation? Use a graph of the related function. Okay, so it says use a graph. We're just going to sketch a graph for our homework and for these examples. I'll do A and you guys could do B and C. So x squared minus 16. First of all, the A value is 1, the B value is 0, and the C value is negative 16. I can just make this a Y right here if I wanted to figure that out, okay, if I wanted to graph it. I'm going to solve this. X squared minus 16 equals 0. Add 16. And I get x squared equals 16. So I get x equals plus or minus 4. So the solutions are 4 and negative 4. So when I sketch a graph here, let's see what this looks like. One solution is going to be at 4 right here. The other solution is going to be at negative 4 right here. The axis of symmetry, since b equals 0, is just going to be the y-axis. And then it's going to go down here to negative 16 because my c value is always my y-intercept. So it's going to look something like this. It doesn't have to be the scale. We're just sketching a graph. So the solutions are positive 4 and negative 4. Hey, pause the video. Try B and C. All right, B. What can I do to solve this? I can subtract 6. I can do 3x squared equals negative 6, divide by 3. And I get x squared equals negative 2. If I take the square root of this, I'm taking the square root of a negative number. So what works there? Nothing. This is going to be no solution. Okay, I can't take the square root of a negative number. And if I were to graph this and plug in some points, you would see that the graph here would start at 6 because the c value is 6, and it would just go up like this, okay? Kind of a narrow graph. Part C, what do I do there? I could add 25. Add 25. I get x squared equals 0. That cancels. So we already know what x squared equals 0 looks like. That's this graph right here. So y equals x squared. So that is going to have one solution. And the solution is going to be 0, 0. Okay, and at any time, if I'm going too fast in the notes, pause it, rewind it, whatever it takes to help you understand it. Okay, using square roots method. This is what our Khan Academy assignment is on. How can I solve using square roots? Well, I have this quadratic equation, 3x squared minus 75 equals 0. I have some steps here to help me. This one says isolate x squared, so I want to get x squared by itself. How can I do that? I can add 75 to each side. So I have 3x squared equals 75. X squared is still not by itself, so I can divide by 3. And when I divide by 3, I get x squared equals 25. I could then take the square root of each side, and I get x equals plus or minus 5. So the solutions, you could say plus or minus 5, or you could say 5, 0 is a solution, and negative 5, 0 is a solution. Okay, pause it, try A, B, and C. See what you get there. I'm going to add 36. Not too tough here. So m squared equals 36. Take the square root of each side, and m is going to be plus or minus 6. Hey, by the way, there's going to be many different ways to solve a quadratic equation. You can't always solve by using square roots. That's why we're going to learn other methods coming up in the chapter. I'm going to subtract 15 on part B. So I have 3x squared equals negative 15. I could divide by 3. I get x squared equals negative 5. I can take the square root, and some alarm should go off in your head there that I can't take the square root of a negative. So therefore, there is no solution here. Remember, a 0 with a slash through it also means no solution. C, subtract 16. And I get 4d squared equals 0. I could divide by 4. And I get d squared equals 0. Take the square root of that, and you do get an answer. The answer is only 0. There's only one solution. Okay, moving on to problem 3. This was just like the warm-up. These are good problems to know how to do. Anytime you're mixing a quadratic equation in there with a geometric formula or a formula from geometry, you got a recipe for an SAT type question. So good to know how to do these. So I have this fish tank here. An aquarium's doing a new fish tank for tropical fish. It gives me some information. It's a rectangular prism. The length is L. And that is twice the width of W. So twice the width of W. And the volume is 420. It also tells me that the height is 3 feet right here. So what I'm going to do is I'm going to do volume equals length times width times height. And I'm going to fill in everything I know. First thing you want to do is make sure that all of these units of measure are all in feet. Okay, if something was in inches, sometimes they'll throw a problem at you where one of these is in inches and one of these is in feet. You want to get them all in the same unit of measure. So you want these all to be feet, which they are. So we're good. So I'm going to start plugging in things I know. This is 420. I know that the length is twice the width. So I'm going to put 2W, and I'm going to put W for the width. And I know the height is 3. All right, and then I have 420 equals 2 times 3, which is 6. So if you want to break this down using some colors, 2 times 3 is going to be 6. And then I have W times W is going to be W squared. And I have, I'll rewrite it over here, 6W squared equals 420, just flip sides. I could divide by 6. And I know that 42 divided by 6 is 7. So this is going to be 7 with a 0 at the end there, 70. And I want to take the square root. So W equals the square root of 70. So my answer could be positive or negative, but I can't have a negative length, width, or height. So I know I'm just taking the positive root. And way back at the beginning of the year, we talked about how you could estimate square roots without a calculator. We can obviously type it in a calculator, but without a calculator, I could say that the two perfect squares that are nearest to 70 are 64 and 81. And the square root of 64 is 8. And the square root of 81 is 9. So therefore, the square root of 70, I would do a squiggly line because it's approximately, is going to be somewhere in between that. It's going to be 8 and something. How do we know that something is? There's a method you could use here. 64 to 70 is 6 numbers away from each other, 70 minus 64. 64 to 81 is 17. The difference is 17. So I know that this is going to be 8 and 16 and 6 17ths. Well, 8 and 6 18ths would be 1/3. So this is a little bit more than 1/3. So this is about 8.4, something like that, 8.4. Okay, what does this mean? Well, the width is 8.4. We answered the question, but if you want to kind of make extra sure that this works, you can actually plug this in and see that you're getting something really close to 420. So I have the length is going to be double the width. So the length is going to be 8.4 times 2. So we could put 16.8. The width is going to be 8.4. And the height was given to us. That's 3. So when I type these in my calculator, let's check what I get here. So I had the square root of 70 to start. That's about 8.36. So I have that. And I've got 16.8 times 8.4 times 3. So that's going to give me, about 420, 423. I rounded up a little bit. So maybe for one of these, I will round down. I get something really close to 420. Okay, so I know that this is going to be approximately 420 feet cubed because these are all feet. And when I have feet times feet times feet, that makes 3 of those, so that's why it's cubed. Okay, hopefully that helps you. Sorry for no audio on the first video, guys.